Hello everyone and very good evening. Good evening, Lakshmi. I hope you all are good and doing well. So today in the class we are going to learn current electricity. Okay. Almost we have discussed a lot in current electricity. Still we need to discuss some more. Done it. So today basically we will be learning circuit shortcuts, then EMF, potential difference between these two, and after that combination of cells in series and parallel, and then we will be learning finally Wheatstone bridge and meter bridge. Okay, so let's start gradually, but before that, let's go through what we studied in the previous class. So in previous class we studied what? If anyone remembers, what we studied in the previous class, we started with series and parallel combination of registers. So when we are connecting registers in what? This is the symbol of registers, right? When we are connecting registers in series, we connect them end to end. So if it is R1, R2, R3 connected like this, then it is in series. And we will say R equivalent is R1 plus R2 plus R3. And when we connect registers such that their both ends are connected together like this. Okay, okay. So let's say, I mean, okay. Okay, let's say these are two capacitors, R1 and R2. So you can clearly see, no, they are in series again. I just wanted to give you one example of parallel combinations. So parallel combinations की अगर आप बात करो ना, take 2 points. Let's say this is one register, this is another, this is third one. Let's say this is point A, this is point B. Then across A and B, we have three registers connected like this, such that what is same here? If we connect point A to a battery and point B to the other terminal of the battery, we will get potential difference same across R1, R2, and R3. And hence, these three registers are in parallel, and we will say R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is how we connect registers in parallel, how we connect registers in series. In series, we connect them like this. Okay? So in series, what is common? What is, physically end to end connected, but uh, potential or current wise, if you talk about, then in series combination, current through all the registers will be same. So here current is going to be same. And in case of parallel combination, potential difference will be same, like this. Okay? After this, what we studied, one more important thing we studied, that is your power. Okay? So if there are registers connected, let's say R1 and R2, and you are connecting this to a battery, and let's say its potential difference is V across the terminals of battery, then what will be the power across register R1. So सबसे पहले आप यहाँ करंट निकालोगे. What will be current in the circuit? Can anyone tell me? What will be current in the circuit in terms of V, R1 and R2? Yes, Renuka, I feel like you are joining after a gap. Yes, what will be current in the circuit if you can tell me? करंट क्या होता है? ओम्स लॉ को यूज करो आप लोग. V इक्वल टू आई आर. ठीक है. So in this circuit, what is the R value? That will be equal to R equivalent. Here R1 and R2 are in what? They are in series, right? Sri Hari. Yes, that's correct. So here R equivalent is equal to R1 plus R2. So current will be potential difference by R. That is R1 plus R2. So this is the current flowing. And if this is the current flowing, then what will be power across? Yes, Lakshmi, that's correct. So what will be power across R1? So power को हमने कैसे लिखा था? I into current के term में भी लिख सकते हैं I square into R. So across R1, it will be I square, that is V by R1 plus R2 ka square into R1. What will be power across P2? Sorry, R2. That you will again write as I square R2. So this is equal to how much? V by R1 plus R2 ka square into R2. This is how we are going to get P1 and P2. Done it? अब देखो, मैंने यहाँ पे पावर का क्या फॉर्मूला यूज किया, आई स्क्वायर आर. नाउ लेट्स टेक अनदर एग्जांपल वेयर व्हाट वी आर डूइंग. We have one register connected like this. We have another register connected like this. Let's say this is R1, this is R2. And now what we are doing, we are connecting it with a battery like this. It has a potential difference V. ठीक है. Now how we will calculate power across R1 and power across R2? How easily we can do without calculating current. So power का formula मैंने क्या बताया, V into I. It can be written in two different ways, this basic formula. If you break V into IR, you will get I square R. If you break I into V by R, क्योंकि I को हम क्या लिख सकते हैं, V by R लिख सकते हैं. So if you break that way, you will get power का formula V square by R. So whenever registers are in parallel combination and you are asked to calculate power across registers, what you should do is you should be using this formula. For series, I used I square R वाला formula. ठीक है. So here you can see across this potential difference maintained is how much? It is V, same as the battery. So across this potential difference is V, across this potential difference is V. So power across 1 you will write as V square by R1 and power across 2 you will write as V square by R2. So this is how we can use the formula of power in different circuits. Okay? But more things will get cleared when you will be doing more amount of questions or more varieties of questions from this portion. Okay? Chalo. Now we will learn certain circuit shortcuts. First, we will go through the concepts. And then at the end of class, if time allows, we will be doing question. If time doesn't allow, we will be leaving our questions for tomorrow. Okay. So in that case, in tomorrow's class, or not tomorrow, because tomorrow it is Sunday, so we will have break. On Monday, we will be meeting again with number of questions. Okay. So आज की क्लास में हम पढ़ लेते हैं. डन है. सो सर्किट शॉर्टकट्स में सबसे पहले देखो यहाँ मैंने क्या किया है. इन दिस ब्रांच ए बी we have three registers R1, R2, R3. I have done something with R2. This something is called shunting. This something is called shunting. ठीक है. इसका मतलब ये है कि if I mean let's say this is connected across a battery and it is not shunted. ठीक है. So यहाँ पे मैं बना रही हूँ उसी डायग्राम को. Let's say it is not shunted, it is like this. So current will go out from here, potential will drop across this. If this point has potential V1, it will have different because current will drop across this resistor. So potential will change from point A to point O. Let's say this is O. So here potential is V2. Again from point O to P, potential will change. Let's say V3. And here also potential will be different. Let's say it is V4. ठीक है. So what you can see, this is R1. R1 के cross potential difference क्या दिख रहा है? V1 and V2. V1 minus V2. R2 के cross क्या है? V2 minus V3. What is across R3? That is V3 minus V4. And when I am connecting a thing like, I'm taking a conducting wire and connecting it like this. What I'm doing is, इस पॉइंट और इस पॉइंट देखो यहाँ पे ना करंट के लिए दो ट्रैफिक हो. ठीक है. वॉट एवर करंट इज कमिंग फ्रॉम हियर, इट विल गो हियर. ठीक है. सपोज करो यू आर गोइंग टू अ मार्केट एंड ऑन द मार्केट अराउंड दैट राउंड अबाउट एरिया जहाँ पे ट्रैफिक डाइवर्जन होते हैं, there you are having two ways to go into. One is so much crowded, another one is, I mean, it's not crowded. ठीक है. So which trajectory or which way you will take? Definitely you will choose the path that is not crowded. Done it. So same will happen with current. When current is reaching here first diagram में देखो. ठीक है. So when current is reaching here, it has two ways. One is this, another is this. Which way has more traffic? Traffic in the case of electrical circuit is what? More resistance. So where there is more resistance, ये तो कंडक्टिंग वायर है, इसका रेजिस्टेंस तो 0 है और इसका रेजिस्टेंस R2 है. सो करंट विल चूज द पाथ थ्रू विच इट विल सी नो रेजिस्टेंस. सो हियर करंट इसके थ्रू जाएगा ही नहीं, इट विल गो थ्रू दिस वे. like this. So this circuit will look like there is R1, there is no R2. It will look like there is no R2, there is just a conducting wire, and then there is R3. It will look like this. So whenever you are shunting any resistors, basically you are making it dysfunctional. It was simply taking it out of the circuit. Okay? Current will not flow into that room. So simply to calculate R equivalent, you need to remove that portion of resistor. Okay? Any doubt, anybody? किसी को कोई डाउट है? You can let me know. No? Okay, Tejashwini, thank you. चलो, no doubt, then we need to move ahead. Now, again, current के division को easy करने के लिए, because later on we will read KCL and KVL that I also will teach to you. श्री हरि, हाँ तुम्हारा कंसर्न सही है. आई मीन आर बाई जीरो करने की क्या, वी बाई जीरो करने की क्या जरूरत है? करंट, आई मीन देर इज it is having no resistance, so simply you are not going to add this resistance, it is zero. So resistance of the circuit will be R1 by R3, sorry, R1 plus R3. Total resistance of the circuit is not zero, right? It is R1 plus R3. Are you getting me? Okay, chalo. No, you should ask question, that is good thing. I mean, if you're reading it for the first time, I mean, wild questions you can get in your head. So it's fine. Now, if current coming here is I, here is I, current will get divided into two parts, I1 and I2. We will learn KCL and KVL, and we will see how we can calculate current I1 and I2 by using KVL, Kirchhoff's voltage loop law. ठीक है, but हर जगह we cannot apply law. We need to have some shortcuts, and this shortcut is coming from KVL itself. But I have just shortened it for you. So if I1 अगर आपको लिखना हो ना, तो सबसे पहले I1 लिखना ऐसे. I mean, this shortcut I am going to tell you only for this circuit, this simple circuit, where there is current coming at a certain junction A, let's say, and at junction A, from junction A, two branches are getting emanated. I mean, it's getting, what should be the easy word? I mean, it's coming out. Okay, so from junction A, two branches are coming out, and these two branches are having resistance R1 and R2. Then how you can define divide current I1 and I2? So I1 का value क्या लिखोगे? Total current I into current I1 is flowing in which arm? R1 arm, right? So on the numerator you will be writing R2, ठीक है? And in denominator you will be writing R1 plus R2. Done it? Simply, same way I2 लिखना है. Write first the total current. We are calculating I2 current through R2. So numerator में you don't have to write R2. The other one, that is R1 divided by R1 plus R2. So this is the shortcut we will be using a lot while solving the questions. From where we are getting this, that also I will show you by using KVL. But for now, you should have idea of this way we can write it. ठीक है? Chalo, there are certain more shortcuts, horizontal plane of symmetry and vertical plane of symmetry for solving complex circuit diagrams. So what is this horizontal plane of symmetry? Just give me some time. So here, if you talk about horizontal plane of symmetry, then let's say across A and B, there is different branches of resistors, and we have to calculate R equivalent across A and B. Just hold on. Okay, if you can wait for 2 minutes, I just need time. Okay, just give me 2 minutes. Okay, there is some problem. There's some issue actually. So I will be back in 2 minutes. Just give me some time. Thank you everyone for waiting. Thank you, thank you, thank you. So now we are going to learn about what horizontal plane of symmetry. So what is the meaning of horizontal plane of symmetry? Suppose you're given a complex diagram that I will give the example. But let's say there is a complex circuit diagram and you have to calculate R equivalent across A and B. So the horizontal line that will draw connecting A and B, this line can be called horizontal plane of symmetry if around this line the circuit is symmetrical. I will give you examples. So let's talk about this diagram. Okay, it looks very complex. Let's locate what. Suppose we are asked to calculate RAB, that is R equivalent across A and B. So across A and B, what you will do first, you will connect a battery. So you connected a battery here like this. Okay, it is done. Now what you will do is, अब क्या करोगे आप? If I talk about horizontal plane of symmetry, then horizontal line पहले आप बनाओ A से पास करता हुआ B तक. So this is the line, right? हमारा लाइन यही होगा ना, दिस लाइन. नाउ ट्रीट दिस लाइन एज अ मिरर. सपोज कर लो ये लाइन एक मिरर है. Okay, so treat this line as a mirror and then try to see if upper portion of the circuit is mirror image of lower portion or not. So here there is a resistor 4 ohm. Here also this is 4 ohm. So it looks like it is, if this is object, then this is the image of it. Similarly, this is image of this. This is image of this. This is image of this. And this one is image of this. So we can clearly see upper portion of the circuit is image of lower portion of the circuit. So here this horizontal line will be called horizontal plane of symmetry. Again, for it to be symmetrical, it is important that if it is 4 ohm, then it has to be 4 ohm. Let's say this is 4 ohm, this is 2 ohm. Then this cannot be mirror image of 4 ohm, right? Both resistances has to be equal. Then and if you see that these are the mirror images of each other, then what you can do is you can wrap one over another. I mean, you can simply fold one over another. इसको कुछ envelope का जो या फिर तुमने ऐसा कुछ पेज देखा ना, जैसे let's say this is the page, ठीक है? This is your page, and I mean, I should take a copy actually, something that I can fold. So let's say this is a copy, right? So half portion अगर तुम्हारा mirror image है, what you can do is, let's say this is mirror image of this. So you can take the half portion and fold one over another. ठीक है? Folding हम कर सकते हैं. So यहाँ पे what you can do is upper portion को जैसे fold कर सकते हो lower portion के साथ. Means C को D के साथ मिला सकते हो if you're wrapping it like this. ठीक है? So C D के साथ आ जाएगा. This 4 ohm will fall on this 4 ohm. डन है. अब मैं तुम लोगों को क्लियरली बताती हूँ. This C will when you will wrap this around AB, then C will fall on D. यानी कि this 4 will fall on 4, this 4 will fall on 4, this 4 will fall on 4, this one on this one, this one on this one. If you are going to wrap it around AB, ठीक है? And falling का मतलब क्या है? If this 4 is falling on this 4, it means they will be in parallel with each other. ठीक है? Okay, Srihari, very good. Very good. Okay, let me check. I will let others do also. Then I will tell you the answer. ठीक है? तो समझ रहे हो ना मैं क्या कह रही हूँ? मैं कह रही हूँ कि हॉरिजॉन्टल प्लेन ऑफ सिमेट्री कब होगा? फर्स्ट क्वेश्चन दैट आई आंसर्ड. It will be then when one portion of the circuit is mirror image of another portion. Then it is horizontal plane of symmetry. If there is horizontal plane of symmetry, you can fold one portion of circuit onto another. And when you are folding, and whatever registers are falling on the other, they will be in parallel. This is done. Okay. One more thing is points that are mirror imaged about horizontal plane of symmetry have the same potential. So that is why I said they are in parallel. So this is mirror image of this one. And then we will say that across this, whatever potential is there, across this also, there will be the same potential. So points that are mirror images about the HPS have the same potential. But it is talking about points. So points की अगर बात करो तो यहाँ पे ये point है और यहाँ पे ये point है. So this point and this point will carry the same potential. Why? Because they are mirror images of each other. There is horizontal plane of symmetry. Done it? And also these registers will have the same potential difference across itself. Then there is vertical plane of symmetry, shortcut to VPS. Okay, and this is more helpful. I mean, mostly questions get solved using the vertical plane of symmetry. We should know both according to situation. We should use whatever fits in easily to the question. Okay, so vertical plane of symmetry is what? Suppose across A and B you have to calculate R equivalent. First you will draw the line like this, AB. This can be horizontal plane of symmetry if one portion, upper portion is mirror image of lower portion. This we have already learned. After that, if this is horizontal plane of symmetry, what you can do is you can draw a perpendicular bisector on it. ठीक है? So मैंने draw किया perpendicular bisector. This perpendicular bisector can be vertical plane of symmetry. Now we will see what are the what are the requirements. So branches, vertical plane of symmetry भी same तभी होगा when this side of circuit is mirror image of this side. ठीक है? So in that case also you will treat this as a mirror and you will see कि both are mirror image of each other or not. So let's talk about again the same diagram. This was what? This was the horizontal line we can draw, and perpendicular bisector of this will cross like this. We have already seen this is HPS. And now if you treat it like a mirror, you can say left hand side and right hand side are mirror image of each other, right? So there is vertical plane of symmetry also. Okay? Here also branches that are mirror images about VPS have the same potential. So whatever branches are carrying the whichever branches are mirror image of each other will have same potential. जैसे यहाँ पे this branch is mirror image of this one, है ना? And so potential drop across it and across it are same. Done it? First thing. Second thing ये है, this is a very important point. Points on VPS have the same potential. So what was VPS? Our VPS was this. So whatever point is lying on VPS will carry the same potential, meaning there is this point lying on VPS, this point lying on VPS, this one, this one. So C is going to have same potential as that of O, and O is going to have same potential as P, and P is going to have same potential as T. So across this potential difference will be zero. So no current will flow through this. Across this potential difference will be zero, and hence no current will flow through this, because when there is no potential difference, there won't be current. And in the circuit, if you have got to know that there won't be current flowing through that, we will simply remove it from the circuit, as we did in shunting case, right? So here also, if you're getting 2 points having same potential, no current flow, you can remove it from the circuit. Okay? And third important point is, if there are knots lying on the VPS, knots ka matlab, not just a point where two branches are coming, but the point where more than two branches are coming or going out. That will be called knot, gath. That is in Hindi, right? So knot lying on VPS can be opened. So here, this is horizontal line, and you can clearly see if you make it a mirror. Upper portion is mirror image of lower. So this is HPS. Now draw a line perpendicular bisector. Okay, and if you use it as a mirror, you can see left hand side is mirror image of right hand side. So this is also VPS, and on this VPS there is a knot line. This is, so you can open this knot. इसको ओपन करने का मतलब क्या है? सी आई हैव डन हियर. सो यहाँ पे जो ये है ना गांठ जो बना हुआ है, देयर इज सम नॉट सॉर्ट ऑफ सिचुएशन, यू जस्ट ओपन इट. सो अगर हमने इसको ओपन किया, दिस पोर्शन विल गो अप, दिस पोर्शन विल कम डाउन. हमने इसको ओपन कर दिया, ठीक है? सो इट विल लुक लाइक दिस. ठीक है, नाउ लेट्स सॉल्व दिस टू सर्किट्स. ठीक है, पहले मैं इसका इक्विवेलेंट निकालूंगी. हाउ आई कैन डू इट? I have to calculate R equivalent across AB. So across AB, we can see it has horizontal plane of symmetry. It has vertical plane of symmetry. Simply from the vertical plane of symmetry, we can easily solve this question. जैसे this point and this point are having what? Same potential. So ये 4 ohm is gone out of circuit. This 4 ohm is also gone out of circuit. And if these two resistors are gone, how you can redraw the circuit? अब देखो, इसको redraw करने में मुझे time लगेगा. You also redraw it in your copies. ठीक है, आप लोग भी ड्रॉ करो. ठीक है, क्या आ रहा है सबका? We are going to remove this 4 ohm and this 4 ohm. ठीक है, ऐसा. And this will look like what? Again 4 here, and again this is 4 here. और ये है तुम्हारा A, ये है B. अब आप क्लियरली देख सकते हो ये दोनों सीरीज में होगा, because whatever current is going that this side, same will come here. So these 4 are in series. So this is in series. These two are in again series, because whatever current is here will be here. Again these two are in series, and these two series are in parallel with each other, right? And again this and this are in series. इसको अगर आप further reduce करोगे तो कैसे ड्रॉ करोगे सर्किट को? लेट्स रीड्रॉ इट अगेन. सो दिस 4 and this 4 will become 8 ohm. So let's take a point A and let's take a point B. So 1 4 ohm I will draw here. ठीक है, now let's come to this branch. This is 4, this is 4, and this 4 will become what? 8. This 4 will become what? 8. So there is 1 8 ohm here, 1 8 ohm here, like this, and then this. ठीक है, and again here there is 8 this 8 ohm ka resistor. This is 8 ohm, this is 8 ohm, and this is 4, This is, you already know, this is 8, this is 8, and this is 4. So अब इसको अगर आप solve करते हो तो क्या आएगा बताओ. This 8 and 8 are in parallel. 8, 8 in parallel will become 4. So overall, if you again redraw it, this was 8. In the middle, this is 4. This is 4, 4, 4, 8. And this is 8, 8, 4 again. So total 12 ohm, because this 4, and this 4, these three are in series, right? So this will become 12, this will become 8, and again this will become 8. Okay? So these three are in parallel. Now you just need to solve it. So 1 by 8 plus 1 by 8 plus 1 by 12, this will become how much? इसको आप 2 by 8 करोगे, so 1 by 4. 1 by 4 plus 1 by 12. Let's do this. So this is your how much? 4 by 12. So this is 1 by 3. R equivalent will be 3 ohm we will be getting. Srihari, you got 4 ohm, right? एक काम करो, जिसको भी थोड़ा भी समझ में अगर दिक्कत हो रही है, यू ड्रॉ द सर्किट स्टेप वाइज. एवरीवन डू इट. किसी को डाउट है तो बताओ. ओके ओके, ठीक है ठीक है, चेक कर लेना. कंफ्यूजिंग हो गया? ओके. देखो, कंफ्यूज नहीं होना है तुम्हें. लेट मी रिमूव एवरीथिंग फ्रॉम हियर. और कंफ्यूज नहीं होने के लिए तुम्हें क्वेश्चंस करते भी रहना होगा. एक चीज और मैं बता दूं. सबसे पहले वर्टिकल, अच्छा एक चीज मुझे बताओ. यू अंडरस्टूड वीपीएस? वीपीएस समझ में आया? ये बताओ. व्हाई वी आर रिमूविंग? Okay, that you didn't understood, because these 2 points are having same potential. And if these 2 points are having same potential, there is no current going through it is. And if there is no current going through this is not the part of circuit, because this is the open part of the circuit. Done it? And so when we will be calculating R equivalent, this portion won't come into account. इसलिए हम रिमूव कर रहे हैं. ठीक है. यहाँ एंड वाई पोटेंशियल इज सेम, दैट इज अकॉर्डिंग टू द लॉ ऑफ बीपीएस. बीपीएस ऐसा क्यों कह रहा है? सो अगेन वी विल यूज दोस कॉम्प्लेक्स केवीएल, वी विल अप्लाई इट, वी विल सी दिस टू आर हैविंग सेम पोटेंशियल. बट आई हैव शॉर्टेंड इट फॉर योर क्लैरिटी. वी आर कीपिंग इट अंडर बीपीएस, वर्टिकल प्लेन सिमेट्री. VPS लाइन पे जो भी पॉइंट्स लाई करते हैं, ऑल पॉइंट विल हैव सेम पोटेंशियल. So this have same potential, no current, and whenever you see there is no current in the branch, you simply need to remove it. ठीक है. So यहाँ भी करंट फ्लो नहीं कर रहा है, यू सिंपली मूव इट, हटा दो उसको, कोई काम नहीं उसका. ठीक है. एंड इफ यू आर रिमूविंग ऑल द unnecessary portions where current are not going, तब आप कैलकुलेट कर पाओगे ना इजिली. यहाँ पे मैंने इसको इसको 4 रखा, इसको 4 रखा है ना. और यहाँ पे क्या था? ये था 4, ये ऐसे गया, ये ऐसे आया. दिस इज दिस एंड दिस इज दिस. अगेन दिस इज 4. And here also again 4, and this is 4. So now you can see here these two branches are in series. These two branches are in series. So 4, 4, this will become 8. 4, 4, 8. This is 4, 4, 8. This is 4, 4, 8. And these 8 and 8 are in parallel, right? Thanush, we removed 2 4 ohms क्योंकि दोनों ही पॉइंट का पोटेंशियल. देखो मैंने क्या बोला, मैंने तुम लोगों को ये बोला कि वट एवर पॉइंट्स लाई ऑन द वर्टिकल प्लेन ऑफ सिमेट्री विल हैव सेम पोटेंशियल. व्हाट इज हियर वर्टिकल प्लेन ऑफ सिमेट्री? दैट इज दिस लाइन, राइट? यही लाइन है ना. लाइन कैसे ड्रॉ करना है मैंने बताया. फर्स्ट ड्रॉ द हॉरिजॉन्टल लाइन पासिंग थ्रू ए एंड बी, देन ड्रॉ परपेंडिकुलर बाइसेक्टर ऑन इट. And if along that perpendicular bisector circuit is symmetrical, then that line will be called VPS. That will hold symmetry, and that is basically vertical plane symmetry. And on this line, that is here line P and Q, along this line, whatever point is lying will have same potential. That is the law. So this point, this point, this point, this point, all these 4 points are having same potential. So if you say here the potential is 10 volt, here also potential is 10 volt, here also potential is 10 volt, here also potential is 10 volt. सो पोटेंशियल डिफरेंस अगर आप इस 4 के अक्रॉस निकालो, जीरो है, सो नो करंट। अक्रॉस दिस यू कैलकुलेट पोटेंशियल डिफरेंस, जीरो है, नो पोटेंशियल, नो करंट। दैट इज व्हाई आई रिमूव these two from the circuit. Understood?
Okay, ma'am. Yes.
Okay, okay, okay. So that is why I removed. I hope now you will be able to do this simple circuit.
Yes,
Okay?
ma'am.
Okay, thank you. So now let's do this question also. यहाँ पे what we did is, second point was, whatever knot is lying on VPS, it can be opened. So here on the VPS there is one knot, that is O. So point O को आप open कर सकते हो. I have opened it like this. And the moment you opened it, circuit काफी clear हो गया, है ना? जब ये knot था, तो ये समझना बहुत ही मुश्किल है, बहुत ही ज्यादा मुश्किल है. These two resistors are in what? These two are in what? How current will will get distributed at point O? It is very complex circuit. But since R value is same everywhere, vertical plane of symmetry is holding, we can open the knot at point O. After opening it is this. So this R and this R, they are end-to-end connected series. These two are in series. These two in series. Again, these two series. These two in series, and overall. You can solve it now, right? So can you tell me answer of this, everyone? Lakshmi, not this won't be the answer as I can see. No. Mhm, mhm, mhm. तुम लोग सर्किट को प्लीज 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 रिड्यूस करते जाओ. सबसे पहले रिड्यूस करोगे तो कैसा दिखेगा? आई वॉन्ट मोर आंसर्स प्लीज. 7/6 r. Isn't it 5/6 r? Because when I'm solving it, I'm getting like that, I guess. सर्किट को तुम लोग ब्रेक कैसे कर रहे हो? ये दोनों हो गया 2r. मैं तो ऐसे डायरेक्ट कर सकती हूँ, देखो आर आर हो गया 2r. दिस आर 2r, दे आर इन सीरीज. एंड दिस 2r and this 2r are in parallel, right? Because if you call this point P, if you call this point Q, along PQ, resistance potential difference across 2r and across this 2r is same, right? So this 2r and this 2r are in parallel, and 2r and 2r in parallel will become what? अगर आप उसको ब्रेक करोगे, 1/2r plus 1/2r कितना होगा? r के बराबर होगा, 1/r इक्विवेलेंट. ऐसा करोगे तो 2/2r 1/r, that is r. सो ओवरऑल अगर मैं बोलूं इस पूरे का इक्विवेलेंट क्या होगा, इस पूरे का, this is r, right? Then this another r is here, another r is here. Done it? So r plus r plus r, 3r. In the top circuit, we will get 3r. In the middle branch, there is 2r. This is r and r in series. And similarly, जैसा upper portion है, वैसा lower portion है. So this also will be your what? 3r. So these 3r, 2r, and 3r are in what? Yes, Srihari, that will be correct. So these three are in what now? They're in parallel, right? So 1/r equivalent आप निकाल लो, 1/3r plus 1/3r plus 1/2r. So this will give you how much? 2/3r plus 1/2r. And this will, sorry, yes, this will give you how much? No, that is 7 only. Okay, that's correct. अरे नहीं, मुझे भी 7 ही दिख रहा है अभी तो. Sorry, somebody gave me 7 wala answer. That is correct. Who was he? Venu. Very good. Sorry. ठीक है, मैंने 1/3R और 1/2R को इन द माइंड आई जस्ट एडिड इट, सो आई डिड द मिस्टेक। यहाँ पे अगर आप देखो तो ये क्या है, 7/6R, सो आंसर विल बी 6R/7, राइट? 6R/7, yes, सो आंसर इज दैट। ठीक है, चलो, सो सिंपल थिंग है, वीपीएस एचपीएस को याद रखना हेल्प करता है। ऐसा नहीं है सारे क्वेश्चंस हो जाएंगे, क्योंकि व्हेन यू विल बी सॉल्विंग क्वेश्चंस इन जेई एडवांस, देयर यू नीड टू डू मोर द इमेजिनेशन थिंग। लेकिन अभी मैं उन क्वेश्चंस को पुट नहीं कर सकती, क्योंकि यू हैव नॉट रिवाइज द बेसिक्स फर्स्ट। सो फर्स्ट यू नीड टू डू अ लॉट ऑफ क्वेश्चन फ्रॉम जेई मेंस एंड जेई or NEET level. Do those questions, and then whoever is going to appear after 1 year in JEE Advanced, they should gradually try solving more complex circuits. Complex meaning there you will require more of imagination, I would say, and more of 3D figures knowledge. That is required, I would say. और वो तुम्हें कोई टीचर नहीं सिखा सकता, let me tell you, that only you can learn by doing the practice. So you should get into solving as many number of questions as you can do. Now let's talk about cell. We don't have to read it in detail. In chemistry, definitely you will be reading it. कौन सा cell, Daniel cell, voltaic cell, something something, you have to read dry cell and all. बट यहाँ पे हमें मैकेनिज्म नहीं पढ़ना, वी हैव टू सिंपली लर्न कि ये सेल क्या होता है। सो सेल इज बेसिकली a battery sort of thing which has energy stored in it, and when it is connected to a closed circuit, when it is connected to something forming closed circuit, it has capacity to give out charges or hence current and hence power. ठीक है, so basically it's a simple device to maintain a steady current in an electrical circuit. अगर तुम लोगों को थोड़ा याद हो, 11th क्लास में भी पढ़ना था, आई रिमेम्बर, इन केमिस्ट्री, in the second yeah, in the second I mean in 11th class you have to study two books for chemistry, right? One is mostly covering your physical chemistry wala portion, and another one is having organic portion, and also the cell wala portion is there. Back then it was there, I don't know if it is now or not. So सेल में अगर तुम लोग थोड़ा भी पढ़े हो, यू मस्ट बी हैविंग आइडिया ऑफ कि यहाँ पे एक दो इलेक्ट्रोड होते हैं, एक और दो इलेक्ट्रोड के बाद हियर देयर इज वन इलेक्ट्रोलाइट sort of thing, there is electrolyte, right? And some reaction is happening such that positive charge is accumulating on one electrode, negative charge is accumulating on another electrode. ठीक है, and as this accumulation starts, the potential difference starts getting generated. And also, since charges are traveling through this media, which is electrolyte, and this is certain sort of media, right? So it will provide certain resistance to the flow of charges. And that is why when we talk about cell, we talk about its internal resistance. Okay? There is a term called internal resistance. So whenever you will draw a cell, there will be a small resistor sort of thing attached with the negative terminal of the battery. And then this hole is called cell. What is its meaning? Its meaning is simple. One is positive electrode, another is negative electrode. And this small resistance R is talking about resistance getting offered by the electrolyte or whatever electrolyte is there. I mean, yeah, it's getting provided by this thing, this media. ठीक है, so cell will have what? Positive, negative electrode and its internal resistance. But this much we need to have in our head for physics. Now we define two things. One is your cell EMF and another is your potential difference. So just now I told you when this R will get felt when you will feel the resistance. I mean, when you will feel that market is too busy, when you will go to the market, right? Or when you will start traversing through the market lanes, right? Then only you will get to know, okay, there is so much crowd. Otherwise, if you are just sitting in the comfort of your home, you cannot tell how busy it is, right? Similarly, this internal resistance will get felt when current will flow through the cell. Okay, so let's not go into complexities of how current flow through cell. None of our business. That will get taken care of by your chemistry teacher. So let's here get to the idea of what is difference between cell ka EMF and potential difference. So let's talk about it. There is this cell. there is this. ठीक है, this positive electrode has potential V plus, this negative electrode has potential V minus. What is the, I mean, no current is flowing here. यहाँ पे कोई करंट फ्लो नहीं हो रहा क्योंकि सर्किट कंप्लीट नहीं है. करंट फ्लोज व्हेन यू गिव इट क्लोज पाथ. ठीक है, सर्किट में करंट या फिर बैटरी के थ्रू करंट तभी फ्लो करेगा व्हेन करंट इज गोइंग आउट ऑफ पॉजिटिव टर्मिनल and it has way to reach to the negative terminal. And since here there is no way shown for currents to reach from positive to negative, current is not flowing. Simple. Because this is open circuit. This is what? This is open circuit. And in open circuit, when we define potential difference, let's talk about this point and this point across the cell. Yes, no, not electromagnetic. It is electromotive force. But it has nothing to do with force. Let me tell you, this name is a little misguiding. जैसे दुनिया का सबसे बदमाश इंसान हो और उसका नाम किसी ने कोई किसी भी रिलीजन का कोई भी गॉडमैन के नाम पर रखा हुआ हो. So that is misguiding, right? Similarly, this is misguiding. EMF, electromotive force. It's not a force. ठीक है? It is simply a driving thing which can drive current through the circuit. ठीक है? So its formula is, I mean, its long form is what? Electromotive force. ठीक है? Now we have to calculate potential difference across point A and B when the circuit is open, when there is no current flowing. Then what you will do? This point A is directly connected to this positive terminal of the battery. So this point A will have potential V plus. Now come to the point B. Between this negative electrode and B, there is one resistor on which potential can drop. Lekin potential will only drop if there is current. If there is no current, no potential is dropping here. It's zero, right? So whatever potential is here at the negative electrode, same potential will be at point B. Because in between point B and negative electrode, there is no drop happening. Done it? So point B का भी potential क्या लिखोगे? V minus. So what is the potential difference between A and B? That you will write as V plus minus V minus. And this is called the EMF of the cell. This is called what? EMF of cell. EMF क्या होता है? EMF is basically potential difference between positive electrode and negative electrode. Nothing else. So this is your VAB. This is called EMF of cell. Now what is the potential difference of cell? Suppose कर लो. Now what I'm going to do is, let's say this was the circuit and हमने क्या किया, यहाँ पे internal resistance था and we completed this circuit. We have made it close. Now current will flow because it has got a closed loop to flow into. Current will definitely flow. Okay. Now if you calculate potential difference between the battery, so between the battery means this is the internal resistance. So between point A and B, because in the previous diagram I have shown you what is the battery. Battery is this whole thing. So if you're calculating potential difference across the battery, you have to take these 2 points like this. You cannot take 1 point here and another point here. No. Whole battery meaning 2 electrodes and internal resistance. So that is why if we have to calculate potential difference across A and B, it will be what? It will be VA minus VB. So here it will be VA minus VB. Now let's talk about VA. So A point is directly connected to the positive electrode. Okay? So it has a potential of V plus. Now B point is what? B point is not directly connected to the negative terminal of the battery. Then there is resistance in between, and through this resistance there is current flowing. And because of this current flowing, there will be potential drop here. How much will be the drop? Drop का value क्या लिखोगे? Current अगर इसके through I जा रहा है, resistance is R, potential drop will be how much? IR. ठीक है? So this will become your V minus plus IR. I will tell you why it is becoming plus. ये हम तब करेंगे when we will learn KVL. ठीक है? अभी के लिए बस ऐसे देख लेते हैं. So V plus minus V minus IR. So this is equal to what? This is V plus minus V minus is what? EMF of the cell. So E minus IR. Done it? So there is two terms, EMF and potential difference. When somebody is asking you EMF, it is talking about E value, that is V plus minus V minus. When somebody is asking you about the potential difference across the battery, then simply you have to talk about E minus IR. ठीक है? This is your potential difference across the battery, and this is called EMF. So EMF is a plain term which is simply difference of potential between positive and negative electrode. Potential difference is then we are calculating when current is flowing through the cell. Okay? And then some potential will drop on the internal resistance. So it cannot be this much. It will be less than this. How much less? As much is getting dropped on the internal resistance. How much will get dropped on the internal resistance? I into R. So E minus IR. ठीक है? कभी कभी क्वेश्चन पूछता है, and so many times it has been asked in NEET. I have seen a lot. Also in JEE means it got asked. So they will tell you कि ठीक है, बैटरी का EMF नहीं, पोटेंशियल डिफरेंस बताओ. EMF is given in the question. Talk about potential difference. So you will simply calculate current in the circuit, and then you will do E minus IR, where R is the internal resistance. So this is what we are going to do. Any doubt, anybody so far? If you have, you can let me know. Come on. Is it clear? Okay, this much silence. बड़े ही शांत हो तुम लोग. No doubt. Anush, Lakshmi. ठीक है, no doubt. चलो ठीक है. So now, very interesting thing. I thought I will be able to finish it today, but I cannot because I really paused a lot. है ना? Because it's very important that you understand topics also. So Kirchhoff's law में क्या है? Two laws are there. One is called KCL and another is called KVL. KCL is what? Kirchhoff's current law. KVL is what? Kirchhoff's voltage law. So one is law regarding current, another is law regarding voltage given by Kirchhoff. He was a scientist. ठीक है? So KVL, KCL क्या कहता है? This is a very common law. I mean, it is saying that if any amount of current is coming to any junction, if you talk about current coming to junction or going out of junction, then whatever current is coming to the junction will be equal to whatever current is going out of the junction.
मैं